See, students will be discussing some give reason part today. I'll try to wrap up the topic, some part will remain, and we will start with science 2 easy lessons henceforth. Okay. Look here, we'll be discussing two give reasons today, and that is twinkling of stars and why do planets not twinkle. Okay, these are the two give reasons, and then we will enter into something called as dispersion of light, which is a very easy part, but this comes as a give reason students. Points कसे लिहायचे बघा. Why do stars twinkle? Point number 1, stars are the heavenly objects which are very far away from us, means from the earth. Point number 1. Point number 2, they are self-luminous, means they emit their own light. Point number 2. Point number 3, as the star light from the stars passes through the earth's atmosphere, as the starlight from the stars passes through the earth's atmosphere, it travels, the starlight travels through air layers, atmospheric air layers of different medium of increasing density. You know that air is denser, density of air is higher close to the earth's surface, and as we move higher and higher from the earth's surface, the density of air decreases, so that during the night times when the starlight enters the earth's atmosphere, it is like they are traveling from rarer to denser medium. As they are traveling from rarer to denser medium, students, yesterday I have already cleared, they bend towards the normal until they reach the earth's surface. They travel a curved path such that for a person standing on the earth's surface, the position of the star appears to be slightly raised. Why? Because curved path of light ray never enters the eyes. The straight line path of the light always enters the eyes, and hence for a person standing on the earth's surface, actual position of star is like this, but because of atmospheric refraction taking place continuously, the starlight is traveling from rarer to denser to more denser to more denser, hence bending towards the normal, and hence it follows a curved path until it reaches the earth's surface. Hence actual position of star is here, but apparent position of star appears to be raised. Point number 1. Point number 2, students, also air is a object which is in motion. Second, third point, density of air layers at different points, or the densities of different layers of air are atmospheric air are different. Temperature is different. Due to these three important factors, that is, first of all, refractive index of different layers is different, density is different, and temperature is different. Due to that, what happens? The position of the star appears to be slightly fluctuating, and that is why the stars twinkle. That is the reason that the stars twinkle. I will repeat it again. Stars are the, what points you are going to remember? Stars are the heavenly objects which emit their own light. They are self-luminous. As the starlight from the stars enters the earth's atmosphere, the starlight enters the air layers of different refractive indices. Reason? Because density of different layers of air are different. Hence starlight undergoes atmospheric refraction continuously. Until it reaches the earth's surface, it follows a curved path. But for a person standing on the earth's surface, the straight line path of light enters his eye. असं कर्व आपल्या डोळ्यात जात नाही, आपल्याकडे स्ट्रेट लाईट जाते डोळ्यात, and hence actual position is like this, but the position of star appears to be slightly raised. Not only that, the position of the star changes continuously. Thodi position of star keeps on fluctuating now and then because of three important factors. One is the density of air at different layers of air is different. Hence refractive index is different, and the temperature of different air layers is different, due to which what happens, due to continuous refraction of light through these changing refractive index and temperature and density, the stars appear to be moving or changing their positions regularly, and hence they appear to be twinkling. That's it. कळतंय? हे एक पॉइंट झाला. So why do stars twinkle? Because of changes in temperature of different layers of air, change in density, change in refractive index. What happens? There occurs change in the direction of light rays continuously, and due to which the position of the star appears to be shaky, not like this zigzag. It appears to be slightly shaky, and that is why the stars twinkle. That's it. Point number 1. आता if stars twinkle, why do planets not twinkle? Planets are non-self-luminous. हे तुम्हाला पहिल्यापासून माहिती आहे की planets do not emit their own light and they are closer to the Earth's surface from the as compared to the stars. They are closer to the Earth's surface. A planet can be regarded as a group of point light sources. A planet can be regarded as a group of point light sources. बारीक 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 पॉइंट टिकले कसे किंवा लाइटिंग चे बल्ब असतात तसे असं एक प्लॅनेट एक ग्रुप ऑफ पॉइंट लाइट सोर्सेस म्हणूया. Such that due to refractive index, if the refraction of one point light source is lesser, if it refracts lesser light, if it refracts lesser light, काय होतं? It is compensated by the other point source which emit more light, and hence the total amount of light emitted or appearing to come from the planet is constant. म्हणजे एकाचं लाईट डिम झाली समजा बिकॉज ऑफ ॲटमॉस्फेरिक रिफ्रॅक्शन, दुसरं त्याचं कॉम्पन्सेशन करतो, दुसरा पॉइंट सोर्स त्याचं कॉम्पन्सेशन करतो बाय एमिटिंग मोर लाईट, and therefore on the overall effect is what? Planets do not twinkle. They appear to be constant light emitting sources. That's it. Here एक तरी stars twinkle का होतात? एक तर त्यांची ॲटमॉस्फेरिक रिफ्रॅक्शन कंटिन्युअसली होते, डेन्सिटी इज डिफरंट, टेम्परेचर इज different, okay, and due to continuous changes in the atmospheric refraction, there occurs change in the brightness of due to atmospheric refraction brightness change होते आणि म्हणून ते ट्विंकल झाल्यासारखे दिसतात आणि शेक झाल्यासारखे दिसतात. That's it. कळते स्टुडंट्स? Okay, I'll repeat it again. Planets are the heavenly objects which do not emit their own light. They are non-self-luminous but closer to the Earth's surface compared to the star. Second, planet can be regarded as a group of point light sources. Due to atmospheric refraction, if one point light source emits less light, it is compensated by another point light source present in its neighborhood which emits more light. म्हणजे overall effect is a constant emission of light. Hence, planets do not twinkle. That's it. हे planetsचं झालं. Third, school levelचे आपण थोडंसं examples करूया. When you look at the tube light or when you look at the bulb via using a scale in front of your eyes, त्या scale मध्ये ना तुम्हाला 7 beautiful colors दिसतात. Okay, 7 beautiful colors दिसतात. Why? Point number 1, light, sunlight, tube light, bulb light or any light, LED light, कसलेही लाईट घ्या, जगातला कुठलाही लाईट घ्या, specifically naturally sunlight. Light is made up of, light is a mixture of 7 beautiful colors which are in the order of violet, indigo, blue, green, yellow, orange, red. ही त्यांची ऑर्डर असते. कळलं? Such that काय होतं माहिती का? Different if you look into precisely light, the specific character of each color is its wavelength. Are you aware of what is wavelength? बरं, this is a wavelength, this is a crest, this is a trough. Distance between two consecutive crest or trough ही wave ही. The wave is subdivided into a crest and a trough, alternate crest and trough. असे जात राहते ते. Distance between two consecutive crest or trough is called as wavelength. You know, sunlight, light, tube light, anything is a mixture of 7 beautiful colors which are in the order of violet, indigo, blue, green, yellow, orange, red. ज्याला विबग्योर म्हणतो आपण. The characteristic of color is wavelength. Wavelength is the distance between two consecutive crests or two consecutive throw for a light wave. Wavelength of different colors is different. Students, the wavelengths which are sensitive to our eyes, आपल्या डोळ्याला दिसणारे, जसं आपल्याला ऐकू येणारी फ्रिक्वेन्सी ऑफ साऊंड, बॅट्सची आणि फ्रिक्वेन्सी आपल्या कानाला येत नाही ऐकू, ऑल दिस म्हणजे एक ठराविक रेंज ऑफ फ्रिक्वेन्सी ओनली कॅन बी हर्ड बाय द ह्युमन इयर. वैसे ही द वेवलेंथ ऑफ लाईट विच इज सेन्सिटिव्ह टू आवर आईज, म्हणजे आपल्याला दिसणारा लाईट कुठले, रेंजिंग फ्रॉम 400 nm. nm म्हणजे नॅनोमीटर. नॅनोमीटर मीन्स 1 नॅनोमीटर इज इक्वल टू 10 raised to -9 meter. So wavelength ranging from 400 nm to 700 nm is sensitive to our eyes, and this all these colors, that is violet, indigo, blue, green, yellow, orange, red, why they are sensitive to us? Because their wavelength range lies from 400 nm to 700 nm. 400 nm is the wavelength of violet range, 700 nm is the wavelength of red color, and therefore these beautiful colors are sensitive to our eyes. कळते? आलं लक्षात? I'll repeat what I said again. Students सांगते, when you look towards light through a scale, you find 7 beautiful colors in the order violet, indigo, blue, green, yellow, orange, red. Why? Because light is electromagnetic radiation. Electromagnetic radiation म्हणजे काय? इलेक्ट्रिक आणि मॅग्नेटिक फील्ड्स असतात म्हणून त्याला. Therefore it is called as electromagnetic radiation. Because light is electromagnetic radiations. The electromagnetic radiation is characterized by wavelength. Wavelength for different colors is different. Wavelength which is sensitive to our eyes is only ranges from, ह्याच्या खालची वेवलेंथ तुमच्या डोळ्याला दिसत नाही, ह्याच्या वरची वेवलेंथ तुमच्या डोळ्याला दिसत नाही म्हणून. ते अलार्म्स आणि हा प्रकार ऐकला तुम्ही, चोर म्युझियम्स मध्ये किंवा ज्वेलरी शॉप मध्ये अलार्म्स लावतात ना, त्यांचे वेवलेंथ्स हे नसतात कारण ते डोळ्याला दिसतात ना आपल्याला. दॅट इज द रिझन. सो वेवलेंथ फ्रॉम 400 nm to 700 nm आर ओनली सेन्सिटिव्ह टू अवर आईज. वी कॅनॉट सी वेवलेंथ बिलो 400 नायदर अबाव 700. आपल्या डोळ्याला सेन्सिटिव्ह नाही येते. nm means 10 raised to -9 meter. Students, violet has minimum wavelength of 400 nm and red has maximum wavelength of 700 nm. Therefore these colors are sensitive to our eyes, and therefore we get to see different colors of light. आता ह्याच्या मागे reason काय? Students, कसं आहे सांगते, as far as vacuum is there, velocity for all colors is same, but when light travels through different media, refractive indices of different media are different. काल तुम्हाला ते लिस्ट दाखवलेली मी. So as far as vacuum is present, velocity of light for all these 7 colors is same. But when light changes, when light passes from one medium to another, like glass to water, anything, then what happens? Velocity of light changes for different colors is different. As the velocity is different, refractive indices of different media are different, and hence angle of refraction of different colors is different. Therefore we see a spectrum of light in the strict order ranging from minimum violet to maximum red. परत सांगते हा, टीचर काय सांगितले, as far as vacuum is concerned, velocity of all the colors is same. But once the medium changes, velocity of different colors is different in different media. Why velocity changes? Because refractive indices of different media for different colors is different. Hence, angle of refraction, or they undergo refraction with angle of refraction for all the colors being different, and hence they appear to be separated out. They separate होतात, and therefore we see a spectrum of 7 beautiful colors. आणि हे सगळ्यात पहिला कोणी बघितलेला? नाही मी, नाही तुम्ही. It was observed by a scientist, the founder actually, who was called Isaac Newton. And what did he do? He took a glass prism and he passed a व्हाईट लाईट. व्हाईट लाईट म्हणजे पांढरा कलर, गैरसमज करू नका. इट्स नॉट व्हाईट कलर्ड लाईट. It is a blender of 7 colors. When white light was passed through this material made of glass, which was called prism, it got split into 7 beautiful colors. मी 3च दाखवले कारण 7 दाखवले गेलं तर तुम्हाला काय दिसणार नाही. So with violet bending the most, हा mean color हा yellow, आणि red bending the least. This phenomena of splitting of light into 7 colors, 7 beautiful colors on passing through a given medium. Here it is prism. This phenomena of bending of this phenomena of splitting of light into different colors on passing through this phenomena of splitting of light into 7 beautiful colors on passing through a medium is called as dispersion of light, and this dispersion of light was first observed by Newton. I'll repeat, what is dispersion of light? It is the phenomena of splitting of light into 7 beautiful colors on passing through a given medium. The medium may be glass, the medium may be water, the medium may be anything. Are you okay with this? That's it. For today I will stop. एक page last राहिली आहे, ती डिटेल मध्ये तुम्हाला शिकवते, and I will introduce you to social health tomorrow, students. Clear? Okay. चलो bye.